Hi guys, Jason here from Fireball Tool. I'm super excited to show you guys what I've been working on for the past 6 months. And it is a cast iron fixture plate, as you can see. Okay. Now this was specifically designed to replace the steel plates that I use from a weld table video. Okay. Upon your guys' request, I got flooded with hundreds of emails requesting where did I get those plates, how do you make them? Well, I decided, well, if there's such a demand for it, you guys that I would make one. But not only did I just make one, I wanted to take it up 10 notches and make it out of a material that really suits welding, and that's cast iron. Okay. And as you can see, this cast iron plate, it has 5/8 holes drilled on 2-inch centers, machined surface for accuracy. All these are precision drilled on a CNC machine. The outside perimeter is 10 by 10. That is also machined, so you can use that as a reference surface also. So it's very square and very flat. And on the back side, as you can see, it has this raised boss on the back. And we'll get to what some of those features are, what this raised boss does, but for the time being, that it adds rigidity to the plate. It keeps the plate stable. It's got these web stiffeners in there to be able to keep the machining at its flattest and keep the tools from chattering as the tools run across this, okay? And then also it has these socket-headed cap screw bolts, so you can physically almost bolt this to any application. All right. Now, what I mean by that, I'm kind of marketing this as a universal fixture plate. We could build welding table surfaces. We could bolt it to several other things, which we'll get into a little bit later. But I have personally replaced my old table surface with these new ones. Take a look at this. And I'm super excited to be able to share with you guys some of the abilities this is going to allow. And we'll get into that a little bit later, okay? So the thickness of the table or the plates are important because I want them to be compatible with the Build Pro ball lock bolts and their fixturing. So as you plop it in the hole and you tighten this up, what needs to happen, if you look there, is that ball needs to sit just right inside that chamfer there. So the thickness of these plates are compatible with the Build Pro tooling, okay? So instead of having a thin plate, we would lose all that opportunity there, okay? The other thing is, as you can see, as this was sitting on the table here, is that raised boss. And if this plate was flat, as you can see, when we put that bolt through there, it would stick past the bottom of the surface. So it allows that offset of the plate to be able to use their existing tooling. So if you wanted to use this on a normal table surface, that wouldn't interfere, okay? And I'll explain to this a little bit later. Or use a head of a bolt. You could use bolts or something through the bottom of the holes and still not interfere on any other application. So I want to take a quick moment here to let's set one of these plates. And before, if you guys remembered, I used a wire to set the heights and levels of these plates. Well, because now I have a machined surface that's flat and known, I wanted to make it just a tad bit easier. So I came up with just a real simple solution, is this machined bar stock, okay? So let's set this plate. As you can tell, it's loose. We don't know its orientation to the rest of the plates. So let's just use this calibration bar to do that. And when I first initially reset the table, these two plates in the center were my, let's call zero, okay? So everything just kind of spreads off of these two plates by the use of this bar. So the bar has these 5/8 precision turned sleeves, okay? And they drop into these holes and the plates. And what that does is it sets, there we go. And what that does is that sets the distance from plate to plate. So now all my holes lay out on exactly 2-inch centers, okay? The other neat thing that does is it also lines the plate for squareness off of this one plate. Okay, so once you get that bar calibrated and bumped in there, you can double check with a straight edge around the table to make sure everything's good, and it is. And then we can proceed to bolt the plate down, okay? And at this time, if you wanted to adjust elevations, you could do that too, okay? So what I don't want you to do when removing this bar, because sometimes it can get what I call it's machinist stuck, which means it's so precise that to try to pull this out by hand is just a little bit tight because you're trying to pull all 4 of those precision pins out of another precision holes, okay? So your first instinct is to grab a screwdriver and just pry them up off this plate. Well, you don't have to do that because I've provided, let's check this out, a set of little screw jacks, okay? And they're just finger tight, so there's no handles on this bar, just for convenience sake. And you just kind of just work this little bar up so that it comes out evenly. And once you get it high enough, it just comes right out. So check that out. It's a brass tipped set screw, okay? So once you get that in, you just thread it back in and off we go. So no screwdrivers, okay, to pry this up. On the other side of this bar is a machined straight edge, okay? So now you can use that straight edge to set the elevations. And what I've noticed that's really handy is I just clamp to plates 0, these 2, and now I can swing this plate around and then put a feeler gauge under here and just raise it up. So it actually set this table up really fast. So I wanted to provide another solution for you guys to be able to calibrate these plates or take them on and off and then recalibrate them again really quickly, okay? So that's the calibration bar. So one more thing, when you're done with the calibration bar, you can either keep it handy or use it as a part of the fixture table when you're done. But all I say is don't remove these socket-headed cap screws because these have been calibrated here at the shop so that you know they're correct and in alignment, okay? So be careful with it. She's a precision tool here. I want to start a new segment to this channel, and I want to call it Shop Science, okay? And as part of Shop Science, I want to be able to do some inventing, some experimentation, and answer questions to things around the shop that I feel that I would like to know the answer to. And a lot of this is not going to be laboratory science. It's going to be stuff like is which material is better for such application. And I want to interject this shop science in between builds. So let's just start one right now. So this is the first episode of Shop Science. So let's give it a shot, okay? What I'd like to do is let's just see about weld spatter, because that's the whole idea of cast iron to me, is the importance is how it handles the welding spatter, okay? And we all know steel is BB catchers, I call them. Anything that the BBs bounces on the steel, it just sticks to. And the cast iron, how does it handle weld BBs? So I've set up this little experiment, a plate, my plate, or Fireball's plate, and a block of steel to make some really hideous welds. And you guys are gonna see some spectacular sparks show out of this. So let's just create a mess on this episode of Shop Science, okay? Okay guys, so you just watched this explosion of spatter erupt on these welding plates right here. And I want to remind you, steel and cast iron, and what we're really looking for is the spatter adhesion and which material handles that adhesion of that spatter better than one or the other, okay? So let's scrape these off and see what happens, okay? So we'll start with the steel. Man. Okay, so those ones aren't coming off. We're either gonna have to grind those off or beat them off with a hammer. And it looks like we have a couple similar ones on the cast iron. So let's see how that handles. For one, 90% of them just came off with my hand. anything smaller than the small stuff. And there we go. The spatter is gone. It left a little tiny impression. Let's see. I could barely, my fingernail barely grabs it. Turned out really good where the spatter was, but overall this was treated with nothing. This is just raw. There's no anti-spatter spray of any kind on any of this stuff. So and what's interesting is now, in order to get the plate back to its original condition, this one is acceptable. This one could be put right back into work. This one we're going to have to alter the surface of some sort. We're either going to have to file, we're going to have to hit it with a grinder, and that's what that's going to do is we're going to end up removing material around the BB also. So over time this could distort the plate, okay, or just cause imperfections in the surface of the welding table, okay. So I find this an interesting experiment. How the material really holds up to real world conditions. So this is one of the reasons why I prefer cast iron over a normal steel table, okay? So I look forward to doing some more experiments on this. Please leave your comments down below and tell me what you guys think, okay? For a conclusion, I hope you guys like these plates. I know they can be used for other things besides just welding surfaces. I got 10 other inventions that these are going to be a component in, so stay tuned for those. But I also want to thank you guys for watching. Please subscribe if you aren't already. It lets me know that you're watching, and I'll see you on the next one. That sucker's hot. Okay.
Got that. That's a grouper.
That sucker's hot. Okay, ready?